Okay, so finding the inverse algebraically, simple enough. F of x is the same thing as y, so y equals 5x squared minus 1. So the first step there is just to swap your x and y. So x equals 5y squared minus 1. And then you need to kind of gradually unwrap that y to get y alone. So I'm going to add 1 to both sides. Obviously, x and 1 are not like terms, so I'm not going to combine those. So this is going to be x plus 1 equals 5y squared. Do not square root here. A lot of people made that mistake. You have to get rid of the 5. You have to get a variable squared alone before you can square root. So you're going to divide by 5 first. So what I have over here is x plus 1 divided by 5 equals y squared. Now that I have that y squared alone, then I can take the square root of both sides. Make sure when you square root both sides, you square root the entire thing. A lot of people just wanted to put it over the top. Make sure you do the entire thing. So my inverse, my f negative 1 of x, is the square root of x plus 1 all divided by 5. To verify, you can pick any number to put in for your x, and we'll run that through that process. I can pick a number here, but it's going to be a little trickier to find one that comes out as a whole number, so I'm going to start by putting something into the original. I'm just going to go with 2. So f of 2, this is my verification, equals 5 times 2 squared minus 1. Make sure you stick with your order of operations here. 2 squared is the first thing you're going to do, not 5 times 2. Always the exponents first. So 5 times 4 minus 1, 20 minus 1 gives you 19. You're going to take that 19, put it into your inverse. So f negative 1 of 19 equals square root 19 plus 1 divided by 5. And then I simplify that. Square root of 20 over 5 is equal to the square root of 4, which is equal to 2, which is what I originally put in up here, which means my verification is good. Thing you have to be careful with verification is if you did the wrong order of operations in your inverse and then you did the wrong order of operations in your verification is probably going to come out okay. So you need to make sure you have that order of operations down, parentheses, exponents, multiplication and division, and addition and subtraction, and you're going backwards to solve. So, any questions on finding the inverse algebraically? Okay, moving on.